Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 183. Page 183. Today's our lesson number 247. Problem number 218 is what we are about to solve. Problem number 218. I hope that the book is in front of you. Read the problem to yourself. It's a very long problem here. It says list T consists of 30 positive decimals. So we have 30 positive decimals. I don't like this marker, it's too thick for some reason, the tip. They go on to tell us that none of which is an integer. Alright, so far so good. The sum of the 30 integers is S. The estimated sum of the 30 integers is E. And how do they define estimate? They said that each decimal in T, in the set T that contains 30 integers, each decimal in set T whose 10th digit is even is rounded up to the nearest integer. Alright, let's make a note of here. So we have 30 decimals. We are told that if the 10th digit happens to be even, we are supposed to round up. And if 10th digit happens to be odd, we are supposed to round down. Well, how many of each do we have? Do they tell us? If a third of the decimals in the T have the 10th digit that is even, alright, third of them are even. So even is 30, third of 30 is 10 of them. So 10 out of 30. And here we have 20 out of 30. Now, as I always remind you, and I know it's bloody obvious, you understand this thing, but I have this uncontrollable urge to point out the bloody obvious. That's what I do, that's what I'm good at, that's my forte. As I always point out to you that when I do the problems in front of you, when we do the problems together here in the video, we go at a very leisurely pace. In the exam you have to do the same thinking, but of course at a decent pace. We're just learning right now, so don't get excited, just enjoy. Do you understand? So we have 10 out of 30 which are even, 20 out of 30 which are odd. And of course if the 10th digit is even, the possibilities are that they might end in a 0.2, 0.4, 0.6, 0.8. Now in reality, of course, they do not have to end in just 0.2. For example, you may have a number like something like this: 1.23456782397, something like this. And that's the number. And when we find something like this with the 10th digit that is even, we're going to round it up to the nearest integer. So this will be rounded to 2. This will be rounded to 2. And this is the rounded number, what they call, and this is what they're calling the estimate. This is the estimate, and this is the real number. And here, what are they looking for? Looking for E minus R, or which of the following would be the values of estimated minus the sum? I'm going to call it, instead of sum, I'm going to call it the real value, actual value, R. So here they're looking for E minus R, and here it will be 2 minus this number here, this nasty horrible number, and there will be some number here, there will be a huge thing here. And that will be the difference here. What I'm trying to point out here is that there are infinite possibility as to what these numbers could be. They don't simply have to end in 2, 0.2, 0.4. And even if they did end up in just 0.2, 0.4, 0.6, again the numbers are infinite. But the point I'm trying to make you understand is that if you look at the answer choices, you will see that they are all whole numbers. So it has to be something like 0.2 times 10. 0.2 times 10 is going to give us 2. 0.4 times 10 because there are 10 of them. If all of them end in 0.4 times 10 will be 4. The answers are all even numbers. They're either negative 16, 6 and 10. What they're trying to point out here is that we need not worry about this complicated scenario. Of course we need not worry about this complicated scenario because the problem as it is bloody complicated as it is. And you only have a couple of minutes to solve the thing. I mean, they have to be reasonable. They cannot expect you to sit there and... So don't worry about these things. You understand? Just keep it simple. Let's keep it simple. Understand the fact that all the answer choices are whole numbers. So obviously we're looking at some simple scenarios like these. Okay, let's get going then. Enough of the talk. So we're looking for, the question is, how much is E minus R? R, as I said, is the real sum, which they're calling S. I'm not going to call it S. It's the real, actual, and the estimate. Or we can call it actual if you like, as opposed to real, but it doesn't matter. Now listen, because they're asking about E minus R as opposed to R minus E, these are the real numbers. Their estimated value would be 0.2 would be estimated as 1, because we are told to round up. If something ends in a 0.4, if it's 2.4, 2.4 will be rounded to 3. Oh, not 2.4 will be rounded to 3, but not this guy. This guy is going to be rounded to, if it's just 0.4, it will be rounded to 1. 0.6 again will be rounded to 1. 0.8 will be rounded to 1. So these are our differences. This represents what they're calling E minus R. E minus R. Are you with me so far? And there are 10 of them. And there are 10 of them. Just stay with me in the story. It's actually not that bad. Once you get a hang of it, it's not that bad. 1 minus 0.2 is going to be negative it's going to be positive 0.8. Positive 0.8 times 10 is going to give us 8. Positive 8. Here it's going to be positive. It's 1 minus 0.4 is going to be 0.6, so it's going to be 6. This will be 2. Oh, sorry. This will be 4. And this will be 2. So that takes care of the 10 numbers that have even 10th digit. 10 numbers out of 30 whose 10 digits happens to be even. And if they all happens to be, if they all 10 of them, if they all happen to be 0.2, all 10 of them, then their sum is going to be 8. I mean the sum of their estimated value minus the real value. That's what we're looking for. How much is E minus R? If they all happen to be 0.4, then this difference between the estimated value and the real value is going to be add up to 6. You understand? And so on and so forth. Let's do this part now. Here they have a 10th digit of R, so they're going to end up in either in a 0.1. Let's leave some room here for us. 0.1, 0.3, 0.5, 0.7, or 0.9. If all 20 of them end in a 0.1, then whatever the number was, 1 minus, it's going to be rounded. It's going to be rounded down actually. It's going to be rounded down. So we're going to round it to 0. We're going to round it to 0. They are all going to be rounded to 0. Again, what we have to understand is that in reality we are not suggesting that 0.9 is the only possibility or 0.7 is the only possibility. It could be 17.7. It could be 17.7. The point is 17.7 is going to be rounded to 17. It's going to be rounded to 17. Or rather, yes, it's going to be rounded one less. It's going to be rounded down. Let's put a box around it. So if something is 17.7, because its 10th digit is odd, it's going to be rounded down to 17. And again, the difference between 17 minus 17.7 is negative 0.7, which is exactly what we see here. We're going to take their differences. And these differences are going to be, this difference right here is going to be negative 0.7, just like we found here. So it doesn't matter whether it is 17.7 or whether it is just 0.7 or whether it is 37.7. The difference is going to be 0.7. The difference between the rounded down version and the actual number is going to be 0.7, the 10th digit. So this is negative 0.7. this is negative 0.9, this is negative 0.5, this is negative 0.3, this is negative 0.1. Voila, so far so good. I'm going to erase this part. And how many are there? There are 20 of them. So these are the again, this is the E, this is the estimated value. Anything that has an odd tens digit, this is going to be the number minus the actual thing, so that cancel each other out, and we're left with just 0.1. So estimated value minus the actual value, and there are 20 of them. There are 20 of them. Okay, we're almost there, just be patient. .1 times 10, 0.1 times 10 would be 1, therefore 0.1 times 20 is going to be 2, but it has a negative sign. So this is negative 2, this is going to be negative 0.3 times 10 would have been 3, 0.3 times 20 would be 6, negative 6. So this must be negative 10, this will be negative 14, this will be negative 18. So far so good? Very good, so far so good. The question was, let's put it up here, E minus R. These are the E minus R. In other words, if we had, listen carefully, what we're claiming is that if we had 20 numbers with the tenth digit of 0.7, 20 numbers with the tenth digit of 0.7, their sum would be negative 14, and if we had 10 numbers with the tenth digit of 0.4, their sum would be positive 16, and therefore the sum of the entire 30 numbers, the difference between their estimated value and the real value, will be positive 6 plus a negative 14, whatever that works out to be. And they're giving us 3 choices. Our job is to see how many of them are actual possibility, if there is something that is not possible. The very first thing that we should notice here, is that the highest sum that we got here is positive 8. And all of these are negative. All of these are negative. So if they do give you an answer choice that is more than 8, it's impossible. Because highest we can get in the positive value is 8. And after that we have to subtract all of these. Because we're going to have 10 of these and 20 of those. So it cannot be more than 8. Is there any answer choice more than 8? Let's look at it. There you go. 10 says, 3, the number, Roman numeral 3 says 10. A, B, C, D, E. Roman numeral 3 says 10. That cannot be possible. It is not, it's impossible for the sum of these 30 difference between the estimated value and the real value to add up to 10, because the highest they can be is, they can't even be 8. The highest cannot be 8, because even if you were to take the smallest, well actually here you can take negative 2 and an 8 is going to give us 6. And then it's going to go down. If you take negative 8, it's going to be negative 10. It can be negative 10. The sum of the 30 numbers can be negative 10, but not positive 10. It can be 6. 8 plus 8 and a minus 2 is going to give us 6. It cannot be 10. Any answer choice that contains Roman numeral 3 is wrong. Let's see what can be crossed out. E is gone, D is gone, C is gone. Oh, there you go. Oh, what do you know? What the hell? Well, that helps a lot. That helps a lot. E is gone because it has Roman numeral 3 in it. D is gone because it's a Roman numeral 3 in it. And C is gone because it's got 3 in it. It's either A or B. And we just said that it can be 6. 6 is going to be this part. I'm going to put it in a different color so you can see it. 6 is going to be the sum of these two scenarios. We'll have 10 numbers ending with 0.2, giving us a 8, and another 20 number ending with 0.1, giving us a negative 2. A negative 2 and an 8 will give us negative 6, which is Roman numeral, which is positive 6 rather, which is 2. So the correct answer must have 2 in it. Well, there you go. Answer is B. Answer is B. I just realized because A says 1 only. No, it's not 1 only, because positive 8 and a negative 2 is going to give us positive 6. Now the first one says negative 16. How do you suppose they're coming up with negative 16? Is it possible to get a negative 16 out of it? Of course it is. Right here is negative 16. I'm going to put it in an entirely different color. Right here is your negative 16. We can have we can have 20 of the numbers here ending with 0.9, which will give us negative 18, and 10 of the number ending with 0.8, which will give us positive 2. A positive 2 and a negative 18 is going to give us our negative 16. So negative 16 is possible. Where is my pointer? I call it pointer. I'm given to understand that in the Orient they call it chopstick. So negative 16 is possible, positive 2 and a negative 18, and positive 8 and a negative 2 is going to give us positive 6. But 10 is not possible. That's all. I think I spent too much time on it. Let's quit it. I think right by this time in the story we are beating the dead horse, I think is the expression. I will see you tomorrow, okay? Bye now.